Our most common object to work with in algebra is going to be an equation. Where an expression just represents a number, an equation actually tells us something. An equation represents a statement that two or more expressions are equal. That is, a statement that two or more expressions represent the same number. So if we have the equation 2 plus 3 equals 5, that tells us that 2 plus 3 and 5 are equal. They represent the same number. If we have the equation 2x plus 3 equals 11, that's telling us that the variable expression 2x plus 3 and the numeric expression 11 are equal. They represent the same number. The equation y equals a half times x minus 4 is saying that the variable expression y and the variable expression a half x minus 4 always have to represent the same number. If we write 3/4 equals 0.75 equals 75%, that's saying that 3/4, the fraction, 0.75, the decimal, and 75%, the percentage, are all equal to each other. And notice when we write a string of equal signs like this, we're saying all the numbers in the string are equal to each other. So this also says that 3/4 is equal to 75%. It's saying that all three of those quantities, all three of those numbers, are actually the same number. And finally, so we have an equation like I equals PRT, which says that the variable expression I and the variable expression PRT are all equal. And as we can see in this example, there are a number of ways that we use equations. When we see an equation, it's worth thinking about how that equation is being used. So in the first example, the equation is just being used to show a fact of arithmetic. We use equations to show the facts of arithmetic. The second equation is giving us a piece of information about x. It's telling us something about how that unknown number x is related to other numbers, right? It's telling us that x has to be a number that when we double it and then add 3, we get 11. So this we can say that this places a constraint, that is, a limit on the values of an unknown number. That next equation, where we have a y and an x, notice there are two values there. So that equation is not limiting the value of y and it's not limiting the value of x. Instead, it's requiring that x and y have a certain relationship. If I tell you what x is, that tells you what y also has to be. If I tell you what y is, that tells you what x also has to be. In that fourth example, where we're saying that 3/4, 0.75, and 75% are all equal, that equation is showing that a value can be expressed in several different ways. It's just showing us different ways of expressing the same number. And finally, that last equation that we met earlier as the simple interest formula is showing us not just a relationship between numbers, but it's showing us a relationship between real-world quantities. That is, it's telling us how the amount of interest is related to the interest rate, the time, and the amount that the interest is earned on. When we want to actually manipulate equations, it's important to think about what sort of equation we have. That is, what form our equation takes. Our simplest equations are going to be linear equations in one variable. Now, that introduces two terms. What does it mean for an equation to be linear? And what does it mean for an equation to be in one variable? Well, an expression or equation is linear if there's a limited number of operations that appear. We're allowed to have addition and, of course, subtraction, because subtraction is just addition. And we're allowed to have multiplication or division by numbers. We're not allowed to multiply variables together. We're not allowed to divide by variables. We're not allowed to take powers of variables. We're not allowed to put variables in exponents. We're not allowed to do any monkey business. We can add and subtract. We can multiply and divide a variable by a number. We can't do anything else to variables and have a linear equation or expression. If something is not linear, then we say it's nonlinear. Now, the number of variables that appear in an expression or equation is the number of different variable symbols that appear. So if we have x appear 57 times, that's still one variable. But if we have an x and a y, that's two variables. So here we have just kind of a list of equations and expressions. And we're going to decide three things. Is it linear or not? Is it an equation or an expression? And how many variables is it in? So I think the easiest thing is it an equation or an expression? And 2x plus 3 does not contain an equals sign, so that's a single expression. Is it linear or nonlinear? Well, here we have addition. Here our variable is multiplied by a number. That's all that's happening. This is linear. And then we have an x and no other variables. So we say that this is a linear expression in one variable. Next, we have 4x minus 5y. Again, no equals sign, so this is just a single expression. Is it linear? Well, we've got subtraction. Here we have a variable times a number. Here we have a variable times a number. That's everything that's happening. So this is linear. How many variables do we have? Well, we have an x, and then we have a y. That's two different variables. So this is an expression in two variables. Okay, next, 3x plus 1 equals 2x minus 7. Now here we do see an equals sign, so this is an equation. When we're trying to decide if it's an expression or an equation, we just look and see if there's an equals sign in there. Is it linear or not? Well, we've got addition and subtraction. Variable multiplied by a number, variable multiplied by a number. That's everything that's happening. So this is linear. How many variables are there? Well, here's an x. Here's an x again. Those are the same variable. So that's just in one variable. Next, we see an equals sign. So this is another equation. Is it linear? Well, there aren't any operations on the right side. We've got subtraction, variable times a number, variable times a number. That's everything that's happening. So again, this is linear. How many variables are there? Well, here's an x, and here's a y. Those are two different variables. So this is a linear equation in two variables. Okay, next one. X squared plus 1, there's no equals sign there. So that's an expression. And looking at this, we see that we're applying this exponent to a variable. We have a power of a variable. So this is nonlinear. Right, so that x to the second power makes this nonlinear. Once we know it's nonlinear, we can stop looking. Just one thing that's not allowed makes it not linear. How many variables? Well, just the x. So this is a nonlinear expression in one variable. Next, here's an equals sign. So this is an equation. And here again, we have x to some power. Since we have x to some power, that's against the rules for something to be linear. This is again a nonlinear equation. How many variables do we have? We have a y, an x, and another x. So we have two different variables. One of them shows up once, one shows up twice. This equation is in two variables. Finally, here we have 2 to the x minus 4. No equals sign, so this is an expression. But we see here's a variable in an exponent. We're taking 2 to the power x. That's definitely not allowed in something linear. So this is a nonlinear expression. Of course, that x is our only variable. So this is a nonlinear expression in one variable. One of the things that we will most often want to do to an equation is to solve that equation. What does it mean to solve an equation? Well, an equation might have one or more solutions. Solutions to an equation are values of the variables that make the equation true. So if there's one variable, we need one value. If there's two variables, we need two values, and so on. So in other words, if we plug in these values for the variables, then the expressions on either side of the equals sign really are equal. To solve an equation, then, just means to find what all of the solutions actually are. Even if we don't know how to solve an equation, if we pick some number, we can decide whether or not that number is a solution. So, for example, we can tell, even without knowing how to solve, that x equals 4 is a solution to the equation 3x minus 5 equals 7, because if x equals 4, we have our left-hand side becomes 3 times 4 minus 5. Multiplying first, 3 times 4 is 12. And then 12 minus 5 really does equal 7. So if we plug in 4 on the left-hand side and evaluate, we get 7, which is the same as the number on the right-hand side. For the second equation, we can tell that x equals 1 is a solution, because if x equals 1, we have, again, I'm going to plug in x equals 1 on the left-hand side and see that I get the number on the right-hand side. So I'll have 2 times 1 squared minus 5 times 1 plus 4. 1 squared is 1, so I'll have 2 times 1 minus 5 times 1 is 5 plus 4. And then 2 times 1 is 2 minus 5 plus 4. And then 2 minus 5 is negative 3. And finally, negative 3 plus 4 really does give us 1. Again, if you're not super comfortable with the arithmetic of negative numbers, or if you'd rather not do the tedious order of operations stuff, once you're to this point, you can go to a calculator. Even for slightly messier equations, we can do this. We can say that x equals 3 is a solution to the equation 3 to the power x equals 5 times x plus 12, because, well, if x equals 3, we have, and now here we have x's on both sides of the equation, so we have to plug into both expressions. Right, 3 to the third power, that means 3 times 3 times 3. That's 9 times 3 is 27. 5 times 3 plus 12. That's 5 times 3 is 15. Plus 12. 15 plus 12 is 27. So here we were just given these solutions. So far we haven't learned any methods to come up with these solutions, and we don't know whether these are the only ones. In practice, we'll often use technology to solve equations in this class. The first equation is something that we're going to learn how to solve right now. The second one is an equation that we could solve by hand in a pretty straightforward way. We're not going to do that in this class, but it's not too difficult. The third equation in example 16 there is an equation that really the only way to find the solution is to use technology or just to use trial and error. Because an equation like that, there's actually no nice algebraic way to manipulate it. So sometimes using technology or using trial and error by hand is the only way that we can solve an equation.